Okay, so in this particular video, I wanted to generate two quantitative variables, right? I think we've done this before based on the correlation. However, what I'm going to do with this, one of the variables, I'm actually going to turn it into a binary variable, right? And I mean, if you're familiar with code, you'll understand what's going on here. But let's go ahead and just look at the app and go from there. And I'll tell you why I did this, why I'm doing this. Okay. Uh-oh. I'm going to still keep this video. It's okay. It's fine. Don't know why it's doing that to me. It's fine. So here on the left hand side are two random variables that are generated from a normal distribution, and at this current moment there's no relationship between these two variables, right, on the left hand side. How on the right hand side I'm fitting a logistic regression model. Okay, and so logistic regression allows you to use various explanatory variables, whether it's quantitative or categorical binary, to predict a binary outcome, which is fine, which is great. But for me, this is where it's kind of funny. I truly forgot, the elements of logistic regression, and I wanted to, remember. So what I'm going to do is I'm just going to increase the sample size to about maybe 500, somewhere around there. Okay, so no association. Kind of can see there's no ability of the one quantitative to predict the other. Same thing in terms of the quantitative predicting the binary outcome. However, let's be extreme. I'm going to be extreme so that we can get the point fast. So extreme. Oh, well, yeah, this is pretty extreme, right? So, all right. So on the left side, what you're seeing is a direct relationship between the two variables perfectly, right? Where X is able to predict Y 100% of the time, right? And then on the right hand side, what you're really seeing is that when X is less than 0, you're going to get a particular outcome, and when X is greater than 0, you're going to get the other outcome. Its ability to discriminate, for those who are familiar with IRT, or item response theory, when the ability to discriminate between the two outcomes, it's perfect. This is a perfect there's a perfect capacity of being able to discriminate. And again, the rationale for that's because the correlation is perfectly one. Anyone knows this. Anyone knows, right? I mean, or if you're familiar with this stuff, this doesn't happen in real life. And so, correlation, let's say 0.6, somewhere along that lines. There's some misclassification. Okay, so you see on the left, there's some association between the X and the Y, right? And the association between the X and the outcome, there's some misclassification on both ends. So you can see here it's labeling this as a 1, but as a 0, but in reality it's a 1, and so on and so forth over here. But yeah, I just wanted to get a better sense of what's going on here. So if I see a relationship between these two quantitative variables, if I see maybe if I would also plot a logistic regression model in terms of, a binary outcome based on the mean, for example, I can get a better gist of what's going on. So this might seem very abstract. I think it's very abstract, but but at the same time, it's the beginning of understanding logistic regression from a novice perspective. Okay, it's from a novice perspective. So let's keep making videos and let's see how we digest this data set. Okay.